The problem is all about climbing stairs, right? You are climbing a staircase. It takes n steps to reach the top, right? Each time you can climb either a single step or two steps. Fine. In how many distinct ways can you climb to the top? Can anyone give me the answer for this? Take 2-3 minutes and try coming up. What are your thoughts? How we can actually go ahead and bring the solution for this? Please go ahead, all of you. We start solving this. Anyone? So basically, you are starting from the ground level, that is level 0. Am I correct? From level 0, you are trying to start off, and you have to find in how many ways I can reach the nth stair. If n is equal to 3, then you can take 3 single steps, or first a single step, then a double step, or a double step and then a single step. So tell me, how should I go ahead and try this? Anyone? Anyone? How to go ahead and solve this? The staircase problem. Let's try visualizing a little bit, right? How actually n equal to 3 is working here, right? So they have asked me, you are starting to move on, right? You have actually started from the 0th stair, right? From the ground level, basically. From here, 2 steps are allowed. Either you can go 1 step up or 2 steps up. Okay. So if I take 1 step up, then I have reached the first stair, correct? I've reached the first stair. If I suppose take another from this particular function call, you tried going ahead with another single step. So you have reached the second stair, correct? And then what you can do? And then what you can do? Anyone? And then from here, what I can do? So I can take another single step. I can take another single step and I would be reaching the third stair. So from here, after the third stair, there is no stair left to climb up, right? So I can just return 1 from here. That's fine. One of the path to reach the third stair. Okay, I have made it till so far. And from one path is already there with confirmation, since I am already reaching the value n equal to 3. So I'm going to be returning 1. That one path I have found out. Then what I'm going to do? From n equal to 2, right? I am back to this function call for from n equal to 2. Can I climb 2 steps up? Is it possible? Is it possible to climb 2 steps up? And you would be reaching n equal to 4, the fourth stair. Is it possible? There is no fourth stair, right? After the third stair, there is no fourth stair that is present to you. So such kind of steps are not allowed. Correct? Such kind of steps are not allowed. Okay, so from n equal to 2, only one step was allowed, which is to reach the third stair for us. Let's go back. From here, no more work is done. So basically, if I am reaching the second stair from there, I can take only a single step to reach my destination. And when this is done, I have found the path. I'm going to be returning from here as well. And it's gonna be returning a single path only. That from n equal to 2, only a single path is possible to reach the third stair. That's what the overall scenario would be looking like. Okay, what about n equal to 1? From here, any other step that is possible. I have tried taking a single step to reach the second step. From second step, I got another path that, okay, fine, do one thing. Do one thing, take another step, reach the destination, and from there onward, start returning the value of 1. What about n equal to 1? From here, what should I do? What about n equal to 1? From here, what should I do? Tell me that. One step. How many paths are possible by taking a single step from n equal to 1? That's what we have found out. Only a single path is possible to reach the destination. Okay, then. What I should do? What else I can do? Can I take a double step from here? And I can try reaching the destination, that is the third stair, directly. Is it possible? So another path I got from here. Another path I got from here. So for n equal to 1, if you are already at the first stair, right, there's going to be two paths that would be possible. One via the second stair and one directly to the third stair. So this would be returning 2. That from n equal to 1, right? If I am transiting beforehand from n equal to 0, if I'm transiting to the intermediary first stair, then overall two paths are possible to reach the destination. Okay, so by taking a single step initially, right? By taking a single step initially, how many paths are possible? We have seen them all. Okay, in overall, two paths overall are possible. We have counted on them. Anything else I can do from here? I can directly take a double step, right? And I can try reaching the second stair. That's also possible. Is it that? You have taken a double step directly and you are already at the second stair. And if I am at the second stair, from here only a single step would be possible to reach the destination. And I would be returning single path from here. That, okay, once I have reached the destination, I have already found a path, and that is single in number as of now, and this would be returned to the previous function call. From here onwards again, one would be returned that, okay, making a transition directly to the second stair, right? You can have just a single path to reach the destination. That one would be returned. So if I'm standing at n equal to 0, by taking a single step to the first stair, two paths are possible. And if you have reached the second stair, right, directly by taking a double step, then again one path is possible. So overall from n equal to 0, how many paths are possible? That's going to be 2 plus 1, return that. Works for all of you? Tell me that. Works for all of you? Tell me that. Works for all of you? Should I repeat anything? How the overall sub problem framing would be looking like? Let's try that. Let's try that in terms of code. So what I should do is that, okay, what I should do in that case, let me just go ahead and try making a helper function, right? For simplicity, public int helper, let's say. Public int helper class solution. Let's try this. And what can happen is that int, let's try this in this manner. What is my current stair number wherever I'm standing? So int current stair, correct? So, and what is the destination? That is n. Nth stair is my destination where I require to reach. So suppose that if current equal to that of n, let me fill the helper function first. If current equal to that of n, then what should I do in that case? Anyone? If current equal to that of n, then what should I do in that case? Public, let me make it static as well so that I can make it, I can call that without any object intervention. If current equal to that of n, wherever I'm standing right now, that's my destination. So I have found a path, return 1 from here, return 1. Then what should I do? There was yet another case, right? By taking some steps, my current stair may go beyond the value of n. That's also a possibility. By taking a single or a double step, right, my current stair may go beyond the value of n, which does not exist at all. So in that cases, I have to return 0. That since such kind of stair does not exist, 0 paths are overall applicable, right, in order to reach this step. So that's what I have to handle. So I can again have a base case that if current has gone beyond n, then I can just say return 0. That's it, return 0. Okay, else what should I do? My current is neither the destination, neither the current is greater than n. That is definitely there is just a single case that's left. What is that? Current is lesser than n. These are the two. two things that are left to me. Okay, this is the only thing that is left to me, by the way. So what should I do in that case? I should say that return. From here onwards, two choices I am having. Take double step, take single step. So whatever paths are possible by taking single step to reach the nth stair, all those paths added to the number of paths, right, that I can have by taking a double step from the current step to reach the nth stair. That's it. Add both of them. That's going to be the number of paths applicable from my current stair. That's it. That's it. And return them as it is, right? Okay, fine. So let me just say that at the end, what I need to return. At the end, what I need to return. Can anyone tell? From the climbing stairs, I'm going to say whatever final value your helper function is returning, right? Just go ahead and start off from the 0th stair initially and pass on the destination as n. Whatever value this helper is returning, finally return that. That's what I'm going to do, right? Okay, so let me try running the test case. Let's see whether we are getting the result or not. We should be ideally. Okay, both of them got accepted. Let me try submitting. Let's see whether that gets accepted or not. Okay, yes. Okay, fine. So for some bigger values of n, that is 44, what is happening is we are exceeding the time limit. We are exceeding the time limit. Okay. Since see here, it is exponential in nature. It is exponential in nature. What is the time complexity? Every function is giving rise to two more function calls, just like Fibonacci series, right? So again, suppose if there are n levels of function calls, right? You are starting off from n equal to 0 and you are reaching the destination value n. From 0 till n, this is the maximum length or branch of my overall function calls. So the maximum depth I am having is roughly n, not more than that. Okay, roughly n is gonna be my depth of the function call, correct? Then what's gonna happen is that overall number of functions I'm gonna execute is 2 to the power n again. So roughly this, and overall complexity would be 2 to the power n. So if n exceeds the value of 30, my approach is gonna fail. So that's why for bigger test cases such as n equal to 44, this value has given me time limit exceeded. It's not gonna work for me. For rest all other cases, it's working. Okay. For bigger values of n, for n more than 30, right? This approach, the exponential time complexity approach, this is not going to work. So this particular thing can be resolved utilizing dynamic programming. Okay, that we are going to get later on, that we are going to see later on. So as of now, the aim to solve the problem was that how actually we can decompose the problem in terms of your sub problems and how to calculate that recursively. So this thing is done. And for smaller cases beyond 30, right, that are lesser than 30, it is completely working. So tell me for one thing, is it clear to everyone? First tell me that, is it clear to everyone? Or even Java is adding up a little bit of latency, that's what I feel. Or might be that had I utilized some faster language such as C++, it would have accepted the solution. Might have happened. Okay, that might have happened. Any doubts you are having so far? Please tell me that. How to decompose the problem one by one. From my current step, I'm gonna take either one step up or two steps up. Both works, correct? Now, after taking an intermediary step to the next upper stair, right? That is just a one step away. How many paths are possible? Again, from my current step, just by taking two steps up, just by going two steps up, how many paths are possible? Okay, how many paths are possible? Add up them all. Add up them all, and that's what is gonna be the number of paths from my current stair. That's it. So overall, from the current function, you are giving rise to two more function calls. And at max, the level can be roughly n. So 2 to the power n is going to be the total number of function calls. Inside the current function, again, just like Fibonacci series, you are doing some condition checks and you are calling some new functions and returning the calculated value. So you are doing some constant work, correct? Just like Fibonacci series, again, I am having no more than 2 to the power n function calls. So complexity is going to be 2 to the power n. Big O of 2 to the power n, that is exponential. Not going to work for value of n beyond 30, roughly, correct? And again, the call stack memory that would be required would be of the order O of n. Okay, similar to that of Fibonacci series only. So this is why we did the problem. Tell me, are these points clear? How to solve this problem? How to solve this problem? Are these points clear to everyone? First, tell me that. Are these points clear to everyone? First, tell me that. If you want me to repeat something, I'm going to do it. Let us take some more problems on recursion. Recursion lead code. Don't think there's going to be some dedicated problem, but let's try. Can try taking this problem, right? Power of 2. Power of 2. So given an integer n, return true if it is a power of 2, otherwise return false. Can anyone try doing this? If the number is a power of 2, then return true or return false. Okay, fine. Just do one thing. Let's have a just have a variation of this question rather. Suppose that if somebody has given you that calculate the power of 2 raised to the power n, let's say 2 to the power n, this is the value you have to calculate, where value of n can be large. Okay, value of n can be large. N can be equal to that of 1000, let's say. This is what you have to do. This is what you have to calculate. Okay, if the value of n can be pretty large, then how you are going to do it? How you are going to do it? Can anyone tell me any approach for this? Can anyone try going ahead? You have to do that recursively, let's say. Then how you are going to approach this? Fast exponentiation should be the problem ideally. Let me just see where I can find it. For all the problems of recursion are typically Fibonacci number. We have already done that among the easier ones. Let me just go ahead and let's say power of 4 or power of 3. Let's see what kind of problems they are so that if we get a straight away variation, we can try solving it here onwards. Uh-huh. Okay, power of 4. So power of 4, right? I don't think we are having it. Let's go ahead and let's see fast exponentiation. This is a very good problem that we need to solve utilizing recursion, right? CPP solution. Don't we have any straightforward problem here? Power x to the power n. Okay, fine. Let's go there. Okay, try this, all of you. Try coming up with an approach. What are your thoughts? But they have given in terms of float, I feel. No, double, right? Initially, let's do that in terms of integer. So let us code that somewhere else in some IDE. Later on, we can handle that in case of your double, right? That's what we can do. They have straight away given in terms of, still that can be done. There is no problem. Double, in terms of double only, I have to return that. But let's first do them for integers, okay? So the problem is you have to calculate the power x raised to n. So typically what you can do is that on the first hand, what I can do is that I can go ahead and try multiplying x n times. Multiply the x n times. And whatever may be the result, just return that. This is can be done, right? So this is basically n times multiplication you are doing, utilizing a for loop that runs from 1 till n. I can do it. So the complexity for this is gonna be O of n. Now the question here is you have to do it efficiently. And efficiently that can be done in O of log n time. Okay, how that can be done, by the way? Can anyone try suggesting any approach? Calculating the power x to n, right? I have to solve that in O of log n time, where n is the power to which x is raised. How I can do it? How I can do it? Anyone? My voice is coming good to everyone, right? Hello, am I audible or not?
Yeah, audible.
Yes, you are audible.
Any problem so far? Any doubts? Any doubts? Hello.
No.
Should I repeat the part or something? Okay, try going ahead. Think in terms of integers. You are to calculate x raised to the power n, where x and n both are integers, right? Where x and n are both are integers. Try coming up with a solution, whatever comes to your mind. Go ahead, all of you, please. Try giving me that in big O of log n time, how I can calculate the entire power. Go ahead, all of you. How to go ahead with fast and exponentiation? Anyone? If somebody has asked you, raise 2 to the power n, where n can be large, right? N can be large. I have to do it in big O of log n time. Then how I can do it? Anyone?
Yeah, we can break the problem like x to the power n, like power of x to the power n, x to the power n by 2 into x to the power n by 2. Again, we will
Exactly.
divide it x
Exactly.
to the power n by 4, n by 4.
Okay, fine. Let's say that you are trying to calculate 2 raised to the power 10. Okay, my where the power is 10, the value of n here is 10, right? How I can try breaking that? I can just say, if I am having the value of 2 to the power 5, right? I can just square it. Am I correct? If you are having the value 2 raised to the power 5, you can square it and you can return that. So I am just ready. I just required to calculate the value of 2 raised to the power 5, right? That is, I can try breaking the problem that, can I try representing 5 in terms of, can I try representing the power n in terms of n by 2 plus n by 2? Okay. If I can, then I'm going to straight away first calculate what is the value of 2 raised to the power n by 2. If I am having this, if the value I'm getting, I can straight away square it. I can straight away square it and I can return the overall value. This is going to be my strategy, right? So basically I'm saying that if it is 2 to the power n here, try breaking that in terms of 2 raised to the power n by 2 and calculate the value of 2 raised to the power n by 2. Okay. Now I am ready to calculate what is the value I'm going to get for 2 raised to the power n by 2. That is 2 to the power 5. Then from here, what should I do? Anyone? From here, what should I do? How can I try representing 2 raised to the power 5, right? So if you just say 5 divided by 2, integer division, it's going to give me the value 2. So squaring the value of 2 square, is it going to give me the value of 2 to the power 5? I can again say that 2 to the power 5, this is the value I require, correct? So I can straight away say, for calculating this, why not to go ahead and say divide 5 by 2? Definitely it's going to give me the integer division value of 2, right? So I'm going to square it. I'm going to square it. I am going to square it. but this is actually giving me the value of 2 to the power 4. Then what should I do? Can I just say here, what if I try multiplying with a single 2? Then it's going to give me the overall value of 2 to the power 5, right? And then I can return this value. Then I can return this value to the previous function call, which was aimed to calculate 2 to the power 5. Correct? So from here, in order to get the overall value, right, I require the value of 2 square. I require the value of 2 square. Then what should I do? I require the value of 2 square from here. What should I do? How can I try break this? 2 to the power 1 into 2 to the power 1 straight away. 2 is an even number for us, right? Can be represented in terms of 1 plus 1. So if you are having the value of 2 to the power 1, you can straight away square that and you can return it. Correct? Now how for this? To calculate the overall value, I require the value of 2 to the power 1. How you can do it, by the way? 2 to the power 1, if you are having this value, how you can do it? Anyone? Anyone? Tell me. 2 to the power 0 into 2 to the power 0. If I say 1 divided by 2, integer division is going to be 0, right? So 2 square, you square it. Sorry, 2 raised to the power 0, you square it. And to that, you add a single 2. It's going to give me the overall value of 2 to the power 1, right? So I know that this value, 2 to the power 0, any number x raised to the power 0 is always equal to that of 1. We are hitting a base case here. Fixed value. This nothing can change this value. Okay, no matter what calculation you do, x raised to the power 0 is always 1. So 1 multiplied by 1. The value is always here. What? The value here is always 1 in that case, right? So if I'm trying to calculate 2 to the power 1, the overall value I'm going to get here is 1 multiplied by 2. So the value of 2 to the power 1 is 2 for us. 1 multiplied by 2. That's going to be returned to the previous function call. Okay, that value of 2 to the power 1, which was dedicated to be calculated in some other function call, I got it. The value returned was 2. Now what should I do here? 2 to the power 1's value, I was waiting here to be calculated, 2 returned. Then what should I do here? The value here is 2 and that would be squared with itself. So overall 4 would be returned to the previous function call. The 2 square, which was depending upon this function call in order to calculate itself, this function call has returned the value 4. So 4 got replaced here. So I can just say if I square 2, if I take a square of 4 with itself, then 4 into 4, it's going to be overall 16 into 2. So 32 would be returned to the previous function call. To value of 2 to the power 5, which was dependent on this function call, right? It has this particular function call has returned 32. Correct? This particular function call has returned 32. 2 to the power 5 value 32 we got 32 into 32. This is going to be returned to the final previous function call 2 to the power 10. So 32 square, whatever may be the value, I think 1024 is the value. This would be returned here and this is going to return the final value of 1024 to the main function. Got it? How we are trying to make it? How we are trying to break it? So basically, if right now you are trying to calculate utilizing the function, you are trying to calculate x raised to the power n, it depends upon, right? It depends upon, it may have a result variable, let's say. It typically depends upon what result f x raised to the power n by 2 is returning, correct? It further depends upon what is the value if x raised to the power n by 4 returns. It further depends upon what if x raised to the power n by 8 returns so far that f does not reaches the value that what x raised to the power 1 is returning. Okay, I can assume that this is going to be my final function call because again, any number a raised to the power 1 is going to be a. Okay, you can keep either 0 as the base case or you can either keep 1 as the base case, right? So typically it's better that we keep 0 as the base case. It's an more in general function elsewhere because we need to handle that separately else, right? Okay, then. So I may assume that from n till 1, for calculation purpose, I may assume that these are the number of function calls we are having. Then how many function calls in total we are making? Can anyone tell? To calculate the nth power, you require to calculate the n by second power. In order to calculate this, I require to calculate the n by fourth power. In order to calculate this, I require to calculate n by eighth power. So far, till I reach 0. How many function calls in total I made? Can anyone tell?
Log n.
Exactly. That's what? That's log n amount of functions you are making here. every function is dedicated to do some calculation, that is squaring the values, okay, checking the base conditions and so on. Not much operations you are going to do inside a simple function, whatever I'm writing. So overall log n functions are going to be executed separately. Overall complexity is going to be big O of log n. Okay, overall complexity is going to be big O of log n. We have already, I think, seen this. And let's try writing the code for this, right? Let's try writing the code for this. So I'm going to write it separately, let's say. I think this code I have already given on the code repo. Let that be public static, and it would be, let's say, initially, or we can just keep it to be long. It's going to return a long integer for us. And what would happen here? Can anyone tell? Public static long. Let the name be power, and it's going to be taking two integers, intx and intn. Or you can also take them in terms of long only. Both of them are holding long integers, right? X raised to the power n, let's say. What I can do is that I can try stating if n is equal to that of 0, n has reached a value of 0, you can just say return 1 straight away. No problem at all. Then what should I do from here onwards? In order to calculate x raised to the power n, what I require? What is the result I require? Long result. It's going to be what? Long result. Bring on the power of x raised to the power n by 2. This is a must requirement for us, right? This is a must requirement for us. Now from here, two cases arise. What is that? Can anyone tell?
For odd power and for even power.
Exactly. What are the cases we need to handle then for odd power and even power? If suppose 2 raised to the power 5 is there, and you have already requested a recursive function to calculate 2 square. This is being stored inside the result. Then to calculate 2 to the power 5, how should I do that? How should I go ahead? Shall I say that res into res? Result square, this is going to give me the value 2 to the power 4. To this, I have to multiply the value of x separately, right? Whatever is the value of x, that is 2 in our case, to the result square that needs to be multiplied, and this overall value should be returned. For any odd power that is applicable. Even if you are trying to calculate 2 to the power 7, let's say, it's going to request to bring 2 cube. What's the value of 2 cube, right? And then this would be stored inside your result variable. Let's say you are going to square it. This is giving me the power of 2 to the power 6. To that, I require to multiply another 2, and overall this result would be returned in terms of what is the value of 2 to the power 7. So I need to have a check. I need to have a check that if the current power I'm trying to calculate, right, if it is odd, then what I require to return? Then what I require to return? Then what I require to return? Return? What return? Tell me.
Result into x.
If n mod 2 equal to that of 1, then what should I return? Return result square into x, right? Extra x would be multiplied in order to maintain the odd power, right? Else I can straight away return result into result. Works? Works? Okay, fine. Then let's try calculating the power, whatever power you may try out. This is gonna give you the result, right?
We should check if n equal to 1, return the x.
Not required. I think this is gonna be handling. It can handle it well, right?
It will comes under the odd cases.
Which one? Yeah, it will come under the odd case, I feel. If n equal to 1, 2 to the power 1, you're trying to calculate, right? This base case will not hit in that condition. And here I'm going to calculate that, bring the value of 2 to the power 0. N integer division by 2, it's going to be 2 to the power 0. Now, corresponding to this function call, the base condition would hit, and it's going to return 1 to the previous function call, correct? Now here, the function dedicated to calculate 2 to the power 1, I'm standing here currently, right? And its result variable is filled with the value 1, correct? Now I'm going to check what is the value of n here. It is odd. Value of n here is odd 1, correct? Then what it's going to say is that what is the value of result? What is the value of result? N is equal to 1 here, x equal to 2 here, correct? What is the value of result here? Square it. So 1 would be squared with itself. Final value would be 1. To that, x would be multiplied. So this would be returned finally to the previous function call. Value of 2 to the power 1 would be calculated as 2, and that's going to be returned to the previous function call. Okay. This is going to be counted in terms of the odd case. Just only one case 2 to the power 0 is going to be sufficient here, right? On this particular base condition, any solution can build up. So let me try running it, and let me just say that power of 2 raised to the power 4, let's say, whatever is the value of n we are having. Let's try. Are we getting 16 or not? Let's try. So we are getting the value 16. No problem at all, right? Try 2 to the power 10. Change the value of n. Try to the 2 to the power 10, let's say. Okay, so it's coming out to be 1024. Any problem we are getting? Try 3 to the power 5. Try 3 to the power 5, right? 3 to the power 5, let's say. I'm trying to calculate. Will that come good or not? 243. It's coming exactly good. Okay, so no problem at all. Fine. We have got the efficient calculation of power recursively. All good here? Tell me that. Can you people do this now? Can this problem be done by you people right now in terms of double? Tell me that. Tell me that. Can you try doing it on your own?
Yeah.
Okay, so I'm giving that over the group, right? Where is it, by the way? Okay, fine. I'll give that on the group and post that. Please try calculating this and return the and try checking whether your solution is getting accepted or not. Fine. Any problem with this question? How to calculate power efficiently in log n time? What is the space complexity, by the way, for this problem? Can anyone tell? What is the space complexity? Can anyone tell me that? What is the space complexity? First, you started off with nth power. It called on for another function n by second power, another function n by fourth power, till I reach the first power or zeroth power, let's say. What is the overall function call I have made? It's going to be roughly log n, right? It's going to be roughly log n functions I'm making. So at max inside the call stack, there's going to be no more than log n function calls. So big O of log n is going to be my space complexity as well. Okay. Every function, what we are typically doing inside a single function, checking the condition, right? Making function calls, checking the condition and doing some calculation, or straight away returning by doing the calculation. Some constant operation only I'm doing, nothing else. So it depends upon if every function, each function is only having constant number of operations to be done, right? Then how many function calls overall we are having? So they are log n. For each function, some constant operation. So that the constant does not matter. It's going to be log n. A big O of log n should be my time complexity. Space should be big O of log n again. Because at max, they're going to be log n function calls into my call stack. Not more than that. Okay, that's it. That's it. Any problem? Tell me that. Any problem related to the previous question, related to the current problem? Do we have any variation of staircase problem that can be done recursively? Staircase problem, lead code. Let me see that, right? Climbing stairs, I think we have seen already, but that didn't go well due to the fact that, yeah, here it is again a question, but this is more or less, this is gonna be count ways to nth stair, right? Count ways to nth stair. Let's see. Okay, fine. So they don't expect exponential time complexity here. They expect a dynamic programming solution, right? So that's why we cannot do it. Definitely one of the way of doing it is utilizing recursion, where we are breaking that in terms of sub problems. And we are trying to bring each and every way in how many ways I can try doing it. But yeah, if you want to do it efficiently, we have to do it via dynamic programming. We can see that later on solution fine once we jump into the dynamic programming part. Yeah. So whatever we have discussed so far, is it clear to everyone? First, tell me that. Whatever we have discussed so far, is it clear to everyone? Hello, am I audible or not?
Yes, sir, it's clear for me.
All of you?
Yeah.
Okay, fine. So next day, I'm giving you a problem that I'm going to discuss. Let me just give it first on the first hand. So we are going to first take the problem of tower of Hanoi, right? This is what we require to do, tower of Hanoi. This is what I'm going to take in the next day first. And then 2 more problems related to recursion, generating all subsets and generating all permutations, right? This is the first thing that we are going to take in the next class. Okay, firstly, tower of Hanoi. Afterwards, generating all subsets, generating all permutations. Okay, works for everyone? Works for everyone? Okay. Let's take that in the next session, and if any extra class required, I'm gonna inform you. Next Friday is holiday for all of you. Am I correct? Next Friday is holiday for all of you. Am I correct onto that part?
Yes,
Yes.
sir. Yes.
All of you can come that day. Okay, we'll discuss that. You can tell me your time preference so that we can have an extra class and we can pace up our recursion part. Again, we need to jump into the backtracking questions afterwards.